Remember, in the key concept here, you have some hints that summarize the lesson. The greatest common factor is what you're looking for in order to factor expressions. We need to use the distributive property to factor those expressions by finding that GCF. So you'll notice here in the original expression and in the factored expression that you have taken that greatest common factor outside the parentheses, and then the factors inside are those remaining pieces of each term. Now we're going to try some work together. Let's take a look at questions 3, 4, and 5. Number 3 has 3 parts to it. So we're looking first for an expression, then we're going to factor that expression, and then we're going to use the factored expression to find the number of each item. So let's start with A. Sahil is putting together supply kits and has 36 packs of X pencils. We don't know how many pencils are in a pack, but we know that he has 36 of them. He has 12 packs of Y crayons. Again, we don't know how many crayons are in a pack, but he has 12 of them. And we know he has exactly 24 erasers. So the expression to show the total number of items would be 36X plus 12Y plus 24. Part B. Now let's use factoring to show how many kits Sahil can make while putting every type of item in each kit. So in order to do this, we need to use the GCF. In this case, the greatest common factor of all 3 terms is 12. So we're going to pull a 12 out in front of the parentheses, and then each factor inside will be the remaining factors that you would multiply by 12 to get that term. So in other words, 36x is the product of 12 times 3x, because 12 times 3 makes 36, and we still have an x multiplied by that term. Okay, what do I multiply by 12 to get 12y? Well, it's just the variable y. In other words, what number is in front of that y? Well, that would be a 1, and we'll get to that in part C. And then what do I multiply by 12 to get 24? And that number is 2. So 12 times 3x makes 36x. 12 times y makes 12y. And 12 times 2 makes 24. So in part C, we're looking for the factored expression to find the number of each item in each kit. Well, let's go back to part B. How many kits can Sahil make? And in this case, he can make 12 kits. Okay, because there are 12, at least 12 of every one of those items. Now let's go back to part C to find the number of each item in each kit. So in each kit, he will be able to put 3 packs of X pencils, because that's the other factor there. He will be able to put 1 pack of Y crayons, and he will be able to put 2 erasers in each of those 12 kits. Now I want you to try number 4. It says show 2 different ways to factor this expression. So the hint that I'm going to give you is factor it once using a positive factor and factor it a second time using that same factor but in its negative form. Stop the video and try this one and then come back and check your answer. Take a look at these 2 options. The greatest common factor of negative 12x, 24, and negative 18y is 6, or negative 6. So if 6 is the greatest common factor, then you will have this expression here. If you pull -6 out in front as the greatest common factor, then you get the second expression there. And notice that each term inside those parentheses is exactly opposite of what you got from the first answer, because you've pulled the negative sign out in front with the 6. Now try number 5. Pause the video while you factor 6x plus 15, and then come back and check your answer. Okay, take a look at the answer. You can see how I factored each of those terms. The greatest common factor is 3, so when you move the 3 out in front of the parentheses and use that distributive property, the 2x and the 5 remain inside those parentheses. Let's try a few more before you're ready for your assignment. Now I'd like for you to try questions 6, 7, 8, and 9. Pause the video while you do this, and then come back and check your answers. Check number 6. Go ahead and check number 7. Now check number 8. And now check number 9. If you're still having trouble deciding how to factor or how to pick out the greatest common factor, come see me and we'll talk. Next, I'd like for you to try questions 11, 13, and 14. Pause the video while you try these questions and then come back and check your answers. Take a look at number 11. In this question, the biggest difference that I noticed is that both terms have a variable attached to them. So even though the variable is not common to both terms, you still have to include the variable inside the parentheses as the other factor. Now let's talk briefly about question 13. Your friend had incorrectly factored that expression there. And if you notice when you factor it correctly, their mistake happens to be in the second term. When x is a part of that greatest common factor, and it's outside the parentheses here, you don't need to repeat it on the inside of those parentheses, because when you multiply 5x times 4y, in that distributive property for the second term, you end up with the 20 and the x and the y on that term. If you were to have the x also on the inside of your parentheses, then you would have to multiply x times x, which would be x squared. And that's not what the expression has. So your friend's mistake was that he or she included x as part of the inside term, when really it was just a part of the greatest common factor on the outside. Now take a look at 14. The first step in factoring an expression is to find the greatest common factor. When you look at the three terms in this expression, the GCF is actually just 2. So what does that expression look like when you factor it? The greatest common factor comes out in front of the parentheses, and inside the parentheses you have the remaining factors that multiply to make each term. So 2 times 6x makes 12x, 2 times 9y makes 18y, and 2 times 13 makes 26. Now go on to the last page. The last 3 questions I'd like for you to try are questions 16, 17, and 18. Again, pause the video while you're working, and then come back and check your answers. Okay, go ahead and check your answer to number 16. Now take a look at the reasoning for number 17. And last but not least, let's check number 18. In number 18, only one answer actually uses the greatest common factor, and that is the third answer choice. However, factoring also works with the first answer to give you an equivalent expression. Now you're ready to try some problems on your own.